Breakpoints. In this part we are going to discuss breakpoints in a more detailed fashion, and also how to use breakpoints with WinDBG. Breakpoints give us the ability to stop the target program at a wanted moment, or maybe at some specific location. In many cases, however, knowing where to stop is really a form of art. We begin with discussing soft breakpoints. Soft breakpoints are those which are based on the int3 instruction. Basically, they work as follows. The debugger replaces an instruction, the instruction which we want to put breakpoint on, with the int3 instruction. Then the target program pauses whenever it reaches the int3 instruction. Later, when we want to continue the execution of the target program, the original instruction is restored. All this process, which we have described right now, is transparent for us when using WinDBG. We begin with the first program, specials.asm. Let's take a look at the source code. We begin by reading the main comment. This program sums all the special numbers from 1 to max special. A special number is determined by the check special function. Let's continue. We see this definition of max special, which is some constant which has this large value. We can also see the data section, which contains only one string. This string will probably be printed to the console at some point. Next we have the text section, where the code resides. Let's begin from the top. The program begins by printing the string sSpecials to the console. Then it calls the function SUMSpecials with one argument, which is maxSpecial. Finally, the program calls printEAX, which is going to print the value of EAX. EAX is probably the result from the invocation of the SUMSpecials function. Let's take a look at SUMSpecials. We begin by reading the main comment of this function. Operation. Sum all the special dword numbers from 1 until bound. Bound is the one argument that this function gets. It is also noted that bound is the maximum dword to check and that the output is inside EAX. Let's understand what this function does. We begin by opening a frame and then keeping a few registers into the stack. We can also see that in the end, we restore those two registers and we destroy the frame. We can also see that in the end of the function, we restore those two registers and finally we destroy the frame. Basically, this function contains only one loop, which is this loop. This function also uses ECX as a counter. It begins from bound and it is decreased in every iteration until it reaches 0, which means that this loop is going to happen exactly bound times. In every iteration, ECX is given as an argument to another function called checkSpecial. This function is going to actually check if the number ECX is special or not. The result is going to be inside EAX. Next, we test EAX. to find out if the number was special or not. Then, only if the number was special, we add ECX into EDX. And by the way, EDX was initially initialized to the value 0, which means that EDX is going to contain the sum of all the special numbers. In the end of the function, EDX is moved into EAX, which means that the return value of this function is the sum of all special numbers. You might be wondering, what is this special number? The truth is that we don't really care at this point. We just care that there is a function that actually does it. If we read the comment of this function, which is called checkSpecial, we can get a basic understanding of what it does. By the operation line, we can see that this function basically checks if a number has some special property. We don't know what this special property is, and we really don't care at this point. This function gets as input one number, which is called num here. And as output, it returns EAX equals 1 if the argument was special, and EAX equals 0 if the argument is not special. We can actually take a look at the code of this function, but it is pretty strange. We can just assume that this function actually does this check. You could take some time later to try to understand what is the special property, but there is nothing really beautiful about it. It is just some random property that I chose. At this point, we have a pretty good understanding of the SUMSpecials function and also of the main part of the program. If you want, you may choose to pause the video at this point to take a look at the program for a few minutes, just to make sure that you understand basically how this program works. Make sure that you understand the SUMSpecials function and also this part of the code. Come back when you are ready. We continue by assembling and then running this program. We open a console. Then we assemble this program. And finally, we run this program. As you can see, it takes some time until the program gives us a result. That is because it had to check many numbers. I remind you that it began from the number 1 and it continued until this number, max special, which is a pretty large number. Let me show you again. The result that we got is the sum of all the special numbers. At this point, we don't really know how many special numbers are. We just know that probably there are some special numbers because the value here is not 0. We continue by opening this program with WinDBG. I copy the path, and next I paste it here, and I pick specials.exe. I got here specials.exe in a paused state, just before it begins, and I also have the command line of the debugger. We begin by discussing some breakpoint commands generally. The first and maybe most important command about breakpoints is BP, which stands for breakpoint. We've already seen this command before. It allows us to put a breakpoint in some location. Usually we begin every program that we debug with this command. Let's explain now what this command actually does. Basically, the symbol .exe that we can see here is really just a number. It is some number that WinDBG knows to calculate. It is some number that WinDBG can infer from the executable file in some smart way. In this sense, WinDBG has done some important work for us, because this way we don't have to find out the entry point ourselves. Just to show you that this is really only a number, we can use the evaluate command to see the contents of this symbol. And we can see that it equals this number. If we want to put a breakpoint on the entry point, we could use this command, or maybe use a more direct command, something like this. Those two commands are exactly the same. Now we use the G command to get the first instruction of our code. We open the disassembly window to view some more instructions, and indeed this is the first instruction of our code. As you can compare here, move ESI as specials and then call print star, which are those first two instructions. Some other important commands. BL allows us to see the list of current breakpoints. As we can see, currently we have only one breakpoint in the list. This is the output of the BL command. Let me explain what we see here. The first number is the index of the breakpoint. The next part says E. E means enabled. We could, for example, disable this breakpoint if we wanted, using the breakpoint disable command, BD. Now if we take a look at the list of breakpoints, we are going to see that this breakpoint is disabled. A disabled breakpoint is just a breakpoint that is not going to work. The debugger just keeps the location of this breakpoint for us in case we want to enable it. We could enable it again using the BE command, breakpoint enable. We just give it the index of the breakpoint, and we get that now the breakpoint is enabled. The next part is the address of the breakpoint, which is in our case just this number. You can see this number also here. There are a few more things here which I don't want to discuss at this point. You could research them yourself if you search for this command in the help menu. Another important command is BC or be clear, which is going to delete a breakpoint or clear a breakpoint. It will actually clear it from the list. If I use, for example, BC0 and I check the breakpoint list again, I'm going to see that it is empty. Let me show you again. I add again the breakpoint at exe entry. Now I have one breakpoint inside my list. I can clear it, and now I don't have any breakpoints in my list. The difference between doing BC and BD is that if you use breakpoint clear or BC, the breakpoint is going to disappear from the list. However, if you just disable the breakpoint, it will not disappear from the list, and you could enable it again sometime in the future.